Welcome friends in Ohm Electronics channel. Today we will discuss about variable or adjustable Zener diode. The TL431 IC are the 3-terminal programmable shunt regulator diode. These monolithic IC voltage reference operate as a low temperature coefficient Zener diode. The TL431 is programmable from V reference to 36 volt, only two external resistors. This device exhibits a wide operating current range of 1 mA to 100 mA with typical dynamic impedance of 0.22 ohm. So this is the symbol of TL431. This is cathode, anode, and this is the reference terminal. And pin configuration is 1, 2, 3, and one pin number 1 is reference pin number 2 is anode, and pin number 3 is cathode. And this is the data sheet of TL431, and here the adjustable output voltage 2.5 to 36 volt, and the sink current capability 1 mA to 100 mA, and output impedance is 0.22 ohm. And this is the operating condition. The VKA, cathode to anode voltage, that is the V reference to 36 volt, that is 2.5 to 36 volt. And the IK, that is cathode current 1 mA to 100 mA. Here the test circuit for VK is equal to V reference. In this circuit, the reference terminal directly connected to the cathode terminal. So the output voltage is equal to V reference, that is 2.5 volt. And in this circuit, the test circuit for programming mode. Here the voltage divider R1 and R2, and output voltage, that is VKA, is equal to V reference, that is 2.5 into 1 plus R1 by R2 into plus R1 into I reference. This is the I reference. So you can set the output voltage between V reference, that is 2.5 to 36 volt. This is the output voltage range of TL431 IC. We know the single diode, Zener diode, is connected in this way. For example, we apply supply voltage 12 volt, and the Zener is we consider 6.2 volt Zener diode. Then the Zener diode will draw the necessary current to maintain the output voltage a constant value 6.2 volt. Here TL431 IC also works in a same way. Now cathode is IK, cathode anode, current IK, the output and the input side. In this circuit, the IC TL431 as a simple 2.5 volt reference. This is more temperature stable than the Zener diode, normal Zener diode. Choose a resistor value R is equal to 470 ohm. And this resistance to limit the cathode current or Zener diode current IK, and which is always less than 100 milliampere. Otherwise, the IC will be burned. Now you can calculate the value of IK. IK is equal to input voltage, that is 12 volt. 12 volt minus 2.5 volt output voltage by resistance 470, that is the 20.21 milliamps. Now we will see practically working in this circuit. This is the TL431 IC, and pin number 1, 2, 3. So this is the reference pin number 1, the anode, and this is the cathode terminal. Reference anode and cathode terminal. I will connect this power supply. This is the positive terminal and this is the negative terminal. And this multimeter, using as a ammeter, and reference terminal which is connected directly to the cathode terminal. This is the cathode terminal. Pin number 3, this is the cathode terminal. And pin number 2, which is connected to the ground. So this is the ground line and this is the positive line. This is the negative line, this is the positive line. So source resistance, that is we consider 470 ohm resistance. Now switch on the circuit. We apply the input voltage just 12 volt as per our this circuit, that is input voltage is 12 volt. Is 12 volt. And you can see current drawn just 21.0 milliampere, which is calculated the value 20.21 milliampere. 20 IK is equal to 20.21 milliampere. Let's see the output voltage, that is 2.49, that is 2.5. So we can vary input voltage up to 26 volt. Here maximum voltage is 15 volt. But the output voltage is always constant, 2.49 or 2.5 volt. Now if we want different output voltage than 2.5 volt, which is the basic reference voltage of TL431 IC, so we simply add a voltage divider circuit. So we just add a voltage divider circuit in this position. So it will be that is R1, R2, that is 470 ohm resistance, source resistance to limit the current IK. This is the output voltage V0. So here the output voltage will be, that is V0 is equal to 2.5, that is V reference 2.5 into 1 plus R1 by R2. If we consider R1 is equal to R2, that is 10K, then the output voltage will be 2.5 into 2, that is 5 volt. R1 is equal to R2, that is 1 plus 1, that is 2, 2.5 into 2, that is 5 volt output. Here this is the R1, R2 is the voltage divider resistance. Now we will see practically in breadboard in this circuit. So just add a voltage divider resistance 10K. So this is the 10K resistance. Switch on the circuit. This is the R1, this is R2. Let's check the output voltage. Here the output voltage is just 5 volt. Here the input voltage is 10 volt, but output voltage is 5 volt. Now we increase the input voltage now 15 volt input voltage, but output voltage always constant 5 volt. Now if we want to continuously different variable output voltage between 2.52 input voltage, which is maximum to 36 volt, then we have to replace a potentiometer. We have to replace here a potentiometer. So switch off. This is the 100K potentiometer. This is the 100K potentiometer. And circuit will be just replace a potentiometer here. So circuit will be this is the output voltage, this is the 470 ohm source resistance, and this is the 10K resistance and 100K pot or 100K potentiometer. This is the input voltage. So in this circuit, the output voltage will be in V reference to input voltage, that is 2.52 input voltage. The output voltage will be 2.52 input voltage. So let's check. Now we will measure the variable output voltage from 2.52 input voltage from this circuit. So let's see how to change the output voltage by the potentiometer. So switch on the circuit. Now input voltage is 0 volt. And just input voltage set at 5 volt. And here the initial potentiometer position is initially minimum value. So the output voltage will be 2.49, that is 2.5 volt. Now we are getting 2.5 volt output. So change the potentiometer position, then we see the output also change. Now we set the output voltage . just 15 volt. Now we can change the position of the potentiometer and we see that the output voltage also change. 4.6, that is 5, now 5 volt. Now we can change the output voltage up to input voltage, that is 15 volt. Now 11, that is the 15.26. So we can vary output voltage any value from 2.5 to input voltage. In my previous video, I have explained the functionality of normal Zener diode, where the output of the Zener diode was constant, almost constant. Today we discuss how we can get the variable output using the TL431 IC, that is called adjustable Zener diode. These components, Zener diodes, rectifier diodes, adjustable Zener diodes, transformer, etc., are widely used in DC power supply circuits. We will discuss various other electronics components which are used in DC power supply circuits in later episode. Thank you.